Hello friends, welcome to the next section, heat maps and dendrograms. The main aim of this section is to get you introduced to clustering. In this section, we will be first constructing a simple dendrogram. Then we will be creating dendrograms with colors and labels and then create a heat map. Moving further, we will generate a heat map with customized colors and an integrated dendrogram and a heat map. We will then create a three-dimensional heat map and a stereo map, and finally, we will construct a tree map in R. In this video, we will generate 10 random numbers to introduce you to the concept of dendrograms. Clustering techniques can be grouped into k-mean clustering and hierarchical clustering. Dendrograms, a part of hierarchical clustering, are tree-like structures with branches and are used in visualization when we do not know the number of clusters in advance. If you guys are interested in building something very similar to the New York Times, then I would highly recommend visiting this flowing data website. The idea of tree maps is not a new one, but this has gained a lot of popularity in recent times. Tree maps are rectangles placed together to form a grid, wherein the size of each rectangle is directly proportional to the data that this represents. A high value would imply a bigger rectangle. The only disadvantage with such a visualization is that humans are not very well trained to distinguish between rectangles of varying sizes, unless the difference is very significant. The main idea behind clustering is to detect groups of data that share some similarity. We partition the data into distinct groups that share some common traits. Clustering has been applied in fields such as biology, finance, and economics. We will make use of dendrograms, which are tree-like representation of clusters, as they help us to study various cluster formations with much more accuracy. The tree structure allows us to cut trees at various heights to distinguish between clusters with dissimilar characteristics. We first generate a random data of 10 observations for this video and a sequence of 10 numbers to label the point. This is the code for doing it. Here, the set.seed5 function defines the starting state of the random number generator in R. We use the rnorm function to generate 10 random numbers, each for x and y axes. If you omit setSeed5, R will generate a new set of random values every time we run the rnorm function. We will also generate a sequence of numbers to label our axes. We will call this vector z. The seq function takes 3 arguments, from, to, and by. In our example, we want to start the series from 1 to 10, and the difference between the values should be 1. Let's run this code. And it's done. Next, we will add this code. Here, the cbind function binds the column-wise 3 vectors together. We use the data.frame function to structure our data in an object of class dataFrame. Once we are done with this, we will run our code. We will now generate a distance matrix in R using the dist function, and this is the code for it. Here, the distance matrix is a compulsory argument of the hclust function. The output of hclust is a cluster object. A very important part of the hclust function is the distance matrix calculated using the dist function. The first argument in the function is the data, and the second argument is the method of calculating the distance. We will use Euclidean distance, but R provides us with a few other choices as well. We can read more about the same by typing $dist in the R console window. You can see the documentation as shown here. The hclust function is a basic R functionality and is used for hierarchical cluster analysis in R. Hierarchical cluster is a method of clustering in which we do not have any prior knowledge of the underlying cluster. The first argument in hclust is the distance. We have already generated the distance matrix in R and stored the values as vector d with class dist. The second argument is the method. This is the agglomeration method. We will use average as a method of agglomeration. Readers can learn a little more about the available choices of agglomeration in R by typing $hclust in the R console window. We have now finished creating cluster. Next, we generate 2 plots, a scatterplot on the left-hand side and a dendrogram on the right side. This is the code for generating scatterplot and dendrograms. The text function is used to apply labels to our scatterplot. The dendrogram is also generated using the plot function, but the arguments are not x and y axes, but the cluster calculated using the hclust function. We will now run this code. As you can see, we have calculated both scatterplot and dendrogram here. We have constructed a scatterplot and dendrogram side by side to make a comparison between the two and further study clustering in our data. As you can see, here the leaves of a dendrogram merge to become a branch as we move up the tree structure. We can also implement the same idea using the actual data in R. We're going to crop the data to make the interpretation of the plot a bit easier. We have not shown the scatterplot for the dendrogram of the US arrests data. The code.txt file consists of the code for generating the same. Readers can compare both the plots and study the formation of clusters. We have also analyzed the same data using the principal component analysis, PCA. This is the code for cropping data. Then we will create the distance matrix. This is the code for it. Next, we need to create the cluster, and this is the code for it. Next, we will plot the dendrogram. This is the code for plotting the dendrogram and scatterplot. Let's run it. From this output, you can compare both the plots. You can learn more about it from the book Introduction to Statistical Learning by visiting this site. That's all in this video. Here you have learned to create a simple dendrogram. Good.